On the other hand of von Mises, Tresca actually deals with a different method of dealing with the yielding. Alright, so Tresca speaks about if you have a sigma 1 and sigma 2 over here, if you still find it familiar, the shearing is in fact over here for such that it's sigma 1 2, sigma 2 2 and 1 1 1, right? So if it's sigma 1 pulling in the two direction, so you have some stresses in the sigma 1 2 direction. Alright, instead of writing sigma 1 2, we can actually write the difference between the sigma 1 1 and sigma 2 2. Alright, so it will be sigma 1 1 minus sigma 1 2. I mean, sigma 1 1 minus sigma 2 2 is your is your shearing. So if your sigma 1 1 is somewhat larger, you're gonna shear in this manner, right? You're gonna shear in this manner. So if your sigma 2 2 is larger, then you can shear somewhat in that manner or whatsoever. Okay, and if it's divided by 2, will actually give you a shearing, right? So therefore sigma 1 2 can be re-represented in terms of this thing. Alright, so sigma 1 1 minus sigma 2 2 will cause a shearing, but because of that, we want to average out their so-called shear, average out their so-called shear values. So therefore sigma 1 1 minus sigma 2 2 over 2 is equals to a shear. And therefore if you were to see over here, it's sigma 1 minus sigma 3 over 2, where is your shear stress. So it's an interaction between your plane 1 and your plane 3 in such the case that happens. Alright, maximum shear stress is between your sigma 1, which is the highest one, minus away your lowest one, so to speak lah. Alright, and it may also be your highest one minus away your the middle one, alright, so to speak. So these are all the T max. Your shear max can be all in terms of all this stuff over here. In terms of 3D, then it's all this. Okay, but what I just want to convey is that all maximum of either 1, 2 or 3. So either one of this is max. So for example, if this is 50, their difference is 50, their difference is 30, and this difference is 60. Then the maximum of all of them is 60, right? So if this 60, so this 60 must be equals to your U criterion, which is the one that we have kept drawing, this particular thing over here. Alright, so this particular 60 stresses with regards to all these components, your sigma 1 and sigma 3 or whatsoever, has to be also within this or exactly at this boundary layer over here. Alright, anything larger than this, you're gonna U. Alright, so therefore so if you still remember, sigma is equals to Sy, your U strength, if that's make it more familiar to you. And therefore this stresses, we call this the shear max, is equals to your U strength. Alright, we have to bring the shear max to the other side, which is equals to sigma y minus shear max, or you can write the shear max minus sigma y is equals to 0. So therefore this is somewhat of another criteria, just like your von Mises, if you remember, your Sy minus away your von Mises stress. Okay, so it's somewhat the same thing. And I may be wrong is that this Tresca U surface is indeed this shape over here. Alright, previously was something like that. Alright, and for the von Mises is something like that. I don't know, but because the von Mises is a bit weird, is because if you were to have a U surface, then the U surface may be an ellipse, and which is shown over here. That's why I keep mixing up between, you see, the Mises ellipse. So these are the things that you may want to really take a look if you're free. What I want to convey is that for uniaxial tension, sigma 1 minus sigma 3 is over 2. Sigma 1 minus sigma 3 over 2 is equals to your shear max. Okay? Or sigma 2 minus sigma 3 over 2 is your thing. It's because what you're looking at is the uniaxial tension is somewhat dealing with this. It's pulling in these directions. But this creates another understanding that if you were to pull this in this manner, then the torque will be somewhat going in this direction. I don't know, because you see, when at first your material is like this, and when you pull, this thing is gonna stretch at this point, so somewhat it's going in this direction. I don't know, so leave you to think about it. As for complex stress state, because you're gonna have 3D, then therefore you need to choose which maximum shear stress you're gonna have, and therefore this is something that you need to really know about it. Alright, then this is somewhat the Tresca stuff, and later on in the next video we'll combine everything together and see how things goes. See you there.